Assistant Professor, Department of Electrical and Electronics Engineering. I think in this series, video lecture series, we are seeing that basic electric circuits are a basic fundamental concepts. So last class we discussed here about current, what is meant by current, how the current is defining, and then for understanding purpose, how the current is flowing from one direction to another direction. All those things we discussed in last classes. Today class we will discuss about the voltage. So next parameter, voltage. So what is meant by voltage? So electron have electric potential energy, and electron located at a ground node has a zero energy. It has changes as it travels between the circuit nodes. So voltage is difference between two nodes. It is called as a voltage. So again I will explain some basic concepts here. See this video. See this image here. So voltage is nothing but it is a force, one kind of force. Okay, so if the force is increases, for example, I am explaining here. So in this voltage segment, right, so this is the force. So this force increases. So what is the purpose of this force? If the force increases, the speed of electron will also get increases. If the force decreases, the speed of the electron also get decreases. That means the voltage and then force, the both are same. So this is normally called as a EMF, that is called electromotive force. So the main motto of the force is we are giving the force to the electrons. Okay, so if the voltage increases, the voltage potential also increases. So we can easily make our electron as high speed. So that means the voltage will give the electrons to make a high speed. That means see this video, GIF image. So the electrons are going to here. So and then electron will get speeded here, and then it will finally get in a overall circuit. So again I will explain in a simulation manner. All right. So I am taking a simulation. Again I will make a one simulation model. Okay. All right. So I'm taking one voltage source here. So that is called as a 2-volt voltage source, because in a DC source. So we are discussing in a DC circuits. That's why I'm taking as a DC series or a DC voltage source here. And then I'm taking one voltmeter. So in order to measure the voltage value. So ammeter, voltmeter here. So voltmeter. I'm connecting this voltmeter to across the load. Okay, and also I'm connecting on lamp load. Okay, so the lamp load to lamp load connected, voltage connected, and then voltmeter is connected to across the lamp load. Right. So now we need to configure the voltage sources. So here this is 2 volt, and then the lamp is operated voltage is 1.5. So I'm taking this lamp load as a 1 volt. Okay, so now I'm simulating. What will happen? See this 2-volt power supply. So the lamp is taking the 60 milliamps. So why the lamp is taking 60 milliamps means the last class we discussed with the help of power equation. So from that power equation, the lamp is taking as a 60 milliamps. At the same time, the voltage across the lamp is 2 volt. Okay. So now how the voltage is taking? That means 2 voltages, 2 volt potential energy is pushing to the load to make as a load in a higher power rating. So next I'm increasing the voltage source here. So 2 volt to 8 volt, right? So what will happen? See, automatically the lamp get damaged here. So this symbol is denoted as lamp get damaged. So because the lamp operating voltage is 1 volt, but I am pushing the voltage as a 8 volt. So in last class, we saying that in current ratio, if the load consumes 60 milliamps, the source can deliver the 60 milliamps current, but it has a capacity of 100 to 200 milliamps. So that is not a matter. But we are not applying that method into voltage sources, because voltage sources we need a exact voltage potential. Otherwise the load get damaged. Again, I'm changing the voltage value here, just 1 volt, but I'm changing the lamp voltage 8 volt. Okay, I'm getting at a 60 volt. See what will happen. So it will consume 8.3 milliampere. Okay, so because I'm giving the 10 volt battery, I'm changing this 10 volt into 1 volt. See here, the lamp is not glowing. Even though the current flow is flowing from 833 microamps, the lamp is not glowing because the lamp needs 10 volt power supply, but the source is only 1 volt power supply. The 1 volt power supply unable to push the electron or push the quantity of electron to go or making the light to glow. So that's why voltage is very, very important. So because voltage will defined based on the force. So if the voltage is decreased, the force is very less amount of force. The electrons unable to move from long distance array to do a certain work. So the voltage is important. The voltage should be same with respect to the load. If the load is 10 voltage, the source should be a 10 voltage. But if the load is 80 milliampere, the source can be above the 80 milliampere supply. So this is the voltage value. So just I'm recalling the concept voltage. So voltage is potential difference between 2 points. Otherwise it is called as a EMF, that is called as a electromotive force. So that electromotive force will give the force to electron to do a one kind of work, such kind of work. Okay, so thank you. We will see on the next topic on